Chapter 5. All right, Chapter 5. This has got a pretty sweet title for Chapter 5. Harshna, let's read it.
Logarithmic, exponential, and other transcendental functions.
Transcendental functions. All right, so that's what we're going to be talking about this chapter. Now, before we started taking derivatives. All right, and then we started doing what? Integrals. Now we're going to take derivatives and integrals both in this chapter. All right, so here we go. This is 5.1a for those people that like to take notes that way. All right, so this is the natural logarithmic function we're going to differentiate today. But before we even talk about differentiation, I want to talk about the integral. So if we do 1 over x dx, and I want to take an integral of it, this could be rewritten as like x to the negative first dx, yes? Well, with our simple power rule, what would we do? We'd add a power. What would be my power now? X to the power of what? 0. Does that work out for us? No, because then I'm also going to divide by what? 0. And then obviously add a constant. But can I do 1 over 0 as an answer choice? No, I can't do that. So there's got to be another method, and that's what we're going to be talking about. So let's look at this. This is one of the definitions of a natural log. I'd like you to write it out. So natural log x is the integral from 1 to x of 1 over t dt. Natural log x is the integral from 1 to x of 1 over t dt. And we know from algebra and pre-calc and all that jazz, this is a reciprocal function. 1 over t is a reciprocal function, so it kind of looks like this, remember? And so what's really happening is if I take an integral, which is what? What's an integral again? Area under a curve. So if I take an integral from 1 to whatever it is, that would be the same thing as taking a natural log of that function. That's how it works out. All right? And so that's how we do what is a natural log x. Now, I want to go a little further. I want to figure out what my derivative of natural log x is. So I want to ddx both sides. All right, so if I take a derivative of natural log x, I got to figure out what that is. So I'm going to take a derivative of this integral. What fundamental theorem can I use to take a derivative of an integral? The second fundamental. So how would I do that? I'd take a derivative of that integral, so I'd end up with what? It's not a trick question, guys. What would be the derivative of that integral? 1 over x. All right, I just substitute in x, but then the derivative of x is just 1, so it just goes away. So by the second fundamental theorem, I've kind of proven the derivative of natural log x is equal to 1 over x. All right, I want to keep moving. Before we do anything with calculus, I want to make sure our pre-calc or algebra skills are okay. All right, so I have natural log of 1. What is natural log of 1? We should know this right on top of our 0. All right. And then if I have natural log of two things being multiplied together, how do I expand that? I add it. All right, I add them. So that's the same thing as saying natural log of A plus natural log of B, right? And then if I have a power property, if I have a natural log of a number raised to a power, what can I do with that power?
It comes out front.
I can bring it out front. And so a lot of the times, to make our life a lot easier, we need to know some of these rules. So I'm going to bring that power out front. And then if I have division going on, that's really what when I expand it? Subtraction. All right? And so we need to know those rules to make our life a lot easier when we actually start doing our calculus. So let's look at this first one. I have natural log of 10 over 9. I want to expand this bad boy. So this is the same thing as saying what? Natural log of 10 minus natural log of 9. Yes? All right, let's look at part B. So now I have natural log of the square root, quantity 3x plus 2. So on this one, how do I expand this? What do I bring out front? 1/2. A 1/2. So now I have a 1/2 natural log of the quantity of what? 3x plus 2. Now, can I expand that further? No, I cannot. All right, that has an addition or subtraction statement in there. Remember last year I said, warning, don't do that. All right.
Yeah.
So,
If there wasn't a 2, we could.
all right, let's look at this next one. So now I have natural log of 6x over 5. And I want to expand this one. So, what would I have? Natural log of what? 6. And then plus natural log of x. And then what? Minus natural log of 5. So that would be my expanding. All right. I'll give you a second to do part D. I'd like you to expand that quantity. He's going to help me out. What do we do? How do I expand this?
You're going to take that 2 ln x squared plus 3. Subtract 5 ln x. Add.
No, we're not going to add here. We're going to subtract. Okay. And then I'd have a 1/3. And then natural log of x squared plus 1. All right. I have a subtraction here because where is it located? It's in the denominator. All right. If you actually had a minus and then you had a parenthesis right there, then you could do it. All right. But really, I just do subtraction right away. All right. Pretty good. All right. So that's all we do for expanding. So we have to know our pre-calc stuff in order to do our calculus. So let's talk about E real quick. E is this irrational number that keeps on going, 2.7182818. Then it doesn't have much of a pattern after that. So natural log E is the same thing as saying the integral from 1 to E of 1 over t dt. Well, this is pretty cool because it actually finds a perfect area from 1 to E, which is just 1. All right, so that's another way to kind of prove it. It's a natural base. Yep. All right. So anyway, that's another definition of E. All right, before we go into calculus, I want you to bust out your calculator. Let's make sure we know how to use them. So let's do natural log of 2. So press in natural log of 2. Make sure we know how to use those buttons. Natural log of 2, what do we get? 0.6931.
Nice.
And then we do natural log of 32. And Hoopin, what do we get for natural log of 32?
3.4657.
All right. And then Joseph, you know what? Let's finish it up. What's natural log of 0.1?
Wait. It's 2.3.
Negative 2.326. All right. Good. All right. Let's bust out our note card. I want to add one more to it right now. So we all have these derivatives on it. So that's kind of nice. So then f of x is equal to natural log x. F prime is equal to 1 over x. We proved it a little bit of time ago for our second fundamental of how that works. However, what can we never forget? The chain rule. All right. So here we go. Now we're going to put it into practice. So let's look at this first one. I'm going to derive, with respect to x, natural log of 2x. So what we do with it is we drop our 2x. And then we always have to remember our chain rule. So we drop it, remember our chain rule. So what gets dropped? Natural log of 2x. I'm taking a derivative of it. So what goes to the basement? 2x. What pops out? 2. How can I simplify it? It's just 1 over x. Now, I want to prove that another way. I want to use pre-calc in there before. So I'm going to expand this one. So that's the same thing as saying what? These are being multiplied, right? So this is natural log of 2 plus natural log of x. And if I were to take a derivative of each one of those terms, what's the derivative of natural log of 2? 0. Because it's a number. Natural log of 2 is 0.6931, blah, 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 right? If I take a derivative of a number, what does it go to? It goes to 0. And then plus, what's the derivative of natural log x? 1 over x. What's the wise man say? Many ways to Tampa. A lot of the times we do want to expand things to make life easier. All right, let's look at part B. So now I have the derivative of natural log of the quantity x squared plus 1. Well, I can't expand this, so that's not going to do it. So, how do we take a derivative of log? Natural log, anyway. Put it at the bottom. So I drop x squared plus 1. But what happens? Chain rule happens, so what pops out? A 2x. And so there's my derivative natural log of x squared plus 1. Good? All right, let's look at part C. So now I need to derive x times natural log x. What's happening with x and natural log x? They're being multiplied. So what rule do we need to use when things are being multiplied together? The product rule. All right. So we need to take the derivative of the first. What is the derivative of the first? 1 times natural log x. And then plus the derivative of the second. So what's the derivative of the second? 1 over x times x. So now we just need to simplify it up. So now I have natural log of x and then plus 1. All right. Pretty good? All right, let's look at part D. So now I need to derive the quantity of natural log of x cubed. This is not natural log x cubed. This is the quantity of natural log x cubed. There is a big difference. All right. So can I bring out a 3 for like before I do calculus? No, I can't. So I have to use what rule going on here? The power with a what? Power with a chain. It's power with a chain. So let's take a derivative. So what gets to be brought out front after we take a derivative? A 3. And then I have the quantity of natural log x squared. Then I need to use the chain rule. Never forget the chain rule. So what needs to be popped out? 1 over x. All right, the derivative of natural log x is 1 over x. So then we're going to simplify it up a little bit. So we're going to put 3 quantity natural log of x squared up top over x. Pretty good? All right, let's look at these two. So the first one, we're going to have f of x is equal to natural log square root x plus 1. And this is where our algebra or our pre-calc properties will really help us. How do we take a derivative of natural log? We drop it, right? Yeah. However, this would be dropped a square root x plus 1. Then I'd have to take the derivative of the square root of x plus 1, right? This isn't too bad. It wouldn't be terrible. However, there's a much easier way. What would be the easier method? Use pre-calc. Use algebra. So what could we be brought out front? A 1/2. So before I do calculus, I want to bring out this 1/2. And now I have this as my function. All right? They're the samesies, right? Now let's take a derivative. So how do I notate taking a derivative? F prime here. All right? It was already in function notation. So I have this 1/2 chilling out front. And then what's the derivative of natural log of x plus 1? What do I do with it? I put it at the bottom. So now I have the quantity x plus 1 down there. And then what pops out by the chain rule? Just a 1. So do I need to worry about it? No. So there's my derivative. Pretty simple if I actually use pre-calc or algebra 2 on it. All right. All right, let's look at this next one. f of x is equal to natural log of this big old beast. So now I have x times the quantity x squared plus 1 squared over the square root of 2x cubed minus 1. Who wants to drop that thing and then take a derivative of it? Anybody? No? No? Good idea. I wouldn't either. All right. So we get this big old log. This big old nasty log. All right. So what do we want to do with this big nasty log? Take it up in big little logs. Let's break it up into little logs. All right. So now, how does this work? What do we get? How would I break this up using pre-calc? Natural log of x, and then what? plus 2 natural log of x squared plus 1. And then what? Minus what? 1/2 natural log of 2x cubed minus 1. All right? So now I took this big log and I broke it up into little logs. Does that make sense? Now, what do I want to do now? I'm taking a derivative. How do we take a derivative of a log? Drop it at the bottom. So now we end up having, what's the derivative of natural log x? 1 over x. Plus, I have this 2 going on. But what do we do with this natural log of x squared plus 1? Where do I drop it? Drop it at the bottom. So now I have x squared plus 1. But what pops out? 2x. What does the 2x get to play with? The 2 to become what? 4x. You guys good with that? All right. And then minus. Now I have a 2 on the bottom. But then what goes on the bottom with it? A 2x cubed minus 1. But then what pops out by the chain rule? 6x squared. All right, 6x squared.
Off the game.
I actually do want to record. So, I am good with you stopping right there. Okay? Calc chat will keep going. Calc chat will keep going because you can simplify it further if you wanted to. Because how do we add and subtract fractions? We need common denominators. Anybody want to? No, me either. All right. The only thing that I might do is I might say the 6 over 2 simplifies to 3. That might be about the only thing I would do. All right. Now, calc chat will keep going. Is that necessarily wrong? No. Okay. However, I don't think it's necessary. Is everybody hearing me on this? Okay. Most of my students make a 5. The biggest category in my classes are 5s. All right. So if I'm telling you I am good with you right here, can you trust me? All right. All right. All right. Good?
Yeah.
All right. I know Miller's going to want to go all the way. I get it. I get it. I get it. All right. Let's do this one. So now I have y equals the quantity x minus 2 squared over square root x squared plus 1. And I want to take a derivative of it. What rule would we have to use if I didn't have any other options? I'd have to use a quotient rule. And honestly, the quotient rule on this one wouldn't be that bad. It honestly wouldn't be terrible. However, this is my logarithmic section, so we're going to use logarithmics. All right. So the first thing we're going to do is we're going to natural log both sides. All right. Just like squaring something or square rooting something, I'm going to natural log both sides. Okay. That's my function. Now, before I do anything to it, I don't want that log that big on the right side. You following me? It's gross. All right. So I'm going to break it up into little logs. So how do I expand that right side? 2 natural log of x minus 2. And then what? Minus 1/2. Very good. All right. And so now I have that. Now I want to take a derivative of it. So what's the derivative of natural log y? 1 over y. Close. dy dx. Remember implicit differentiation? Who am I taking this derivative with respect to? X. My function's in terms of x. So I have to have a dy dx being popped out. Because what's the derivative of y? dy dx. You follow me? All right. So then let's work with the right side. So now I end up having, what's the derivative of this 2 natural log x minus 2? 2 over x minus 2. And then what's the derivative of this one? So now I end up having minus 1 over 2 times x squared plus 1. But what pops out? A 2x. All right. Now, one thing that I might change up on it is I'd get rid of my 2's on that right side. All right. So these 2's would cancel. Now, what could you do on this? Common denominators. I don't want to. All right. However, have I solved for my derivative yet? No, I haven't. How do I solve for my derivative? Okay, instead of dividing by 1 over y, what do we really do? We multiply by y. Okay, I'm going to multiply by y on both sides. What is y? It's what we originally started with. And so now I end up having 2 times x minus 2 minus x over x squared plus 1, and then multiplied with what? X minus 2 squared over square root x squared plus 1, that quantity. All right. Now, could you simplify it further? Yes, I don't want to. All right. I am good with it just like that. What's a derivative? Slope of a tangent line. So what we just found was we found the slope of that function. All right, pretty good. All right. 3 through 6 all, 21 through 30 all, 44 through 66 even, 101, 103, 105.